floor so far is that it appears the elevator shaft is what's left up here. We have a radius balcony here. This is partially left and a wrap around this direction. What I see is that it looks like we're back to shear planes again. So just like the Hard Rock Cafe, as the person said, it looks like the Hard Rock. Is that we're back to shear planes, what I call shear planes, meaning I could break the legs out of here, right? These support columns out. Now it's got an overhang, a cantilever that's got to support everything. So if I get these legs to fail, all this cantilever can't hold itself up, so it falls down, directly down, not rotating down. It falls down. As it does that, it shears itself away from the structure. So it shears itself away from the structure, and amazingly so. You're lacking large sections of concrete. Each one of these you'll put together in a floor. So this would be a floor here, a living area, floor, and it appears that steel was not one of their favorite creations here. This is all a concrete reinforced building. I don't see any steel down there, minus the rebar that's inside the concrete to reinforce it. Here it is again. It's creating what I call the shear plane. That's why it stopped there. So the progressive collapse started somewhere in this structure, and it stopped here. It couldn't pull the rest of it down, progressive collapse it. Here are the supports here underneath my mouse, again here and here. So I'm going quickly to, if we leave out sabotage, right, leave that out. It could even be a car that rammed into one of these posts and caused this to progressively implode inwards. So if you take out the center post, this would cause it this would be a cantilever at this point. The span would be from here to here. That would cause it to, the deck to fail in the middle and all the way up top, because the supports probably are center line of this post all the way up. So one post could cause all of this to fold inwards like a book, like you put two books together and fold them in. Here's the pool. I mean, it's huge. I want to see what this building looks like before the collapse. Here's the shear planes I talked about. Look how perfect they are. Ripped it right off. All right. These are the rooms, right? Obviously. There's the engagement right there. I guess the decks. It might be rebar, just pulled out. The pull out. Let's see. Miami Jewish neighborhood building. Okay. Is this an image of it before? No, that's after. Oh, so it did say Miami Jewish neighborhood building. Well, I don't know. This could be an act of a nefarious act, if you will. You gotta consider that. I'm trying to find a building before. These columns to support my theory. This looks like a column leaning here, kicked outwards. So, and I would guess that would be the base column. I wish we had a larger image of that. And these are what? No, these are what? These are what? We need an image of this thing before. Look at these columns. And the reinforcement right here is, I'm so against aligning reinforcement up. I don't care about your overlap. I'm a stagger person. I believe staggering changes your shear plane. I don't know if that was going to help it, but definitely there's some type of what larger support at the base would have helped, wouldn't it? Let's see. Now, can we get this to collapse from the top down? If the floors are so inclined, if they're so inclined. I don't mean literally like inclined. If they're that structurally weak, one floor above could hit the floor below it and start doing that. But you would see a pancaking effect, and the top floor usually would be intact. I've seen it pancaking a few times now. Top floor is usually the one that is the most intact. Here we go again. There's that shear plane. Where is it? Okay, we got a daylight image. So yes, it went all the way over to here. Okay. No, I was wondering what's attached to this part of the structure there. What are we looking at, living room or not? If there was just some type of gap like that. Was there a gap like that? Here we go. We got a close up. Yeah, it is rebar. So that's rebar reinforcement through there, and we can see the angle. All right, we get the angle. We see the AC units. No, they clustered all the AC units up there. That's amazing. All right. Okay, so we got a downward, we got an inward implosion too. If you look at the railings, they're all turned in the same angle like this. See how they're turned on the same angle? So the building went that far before it sheared free the decking of the railings, and it was consistent. Our reinforcement shows the direction of the pullout. So this was bent that way, so it was towards the middle on this one. So the left side of the structure, if we look at it from my view, the left side went that direction. A little bit of rotation there. There's quite a bit of rotation here at this point. And now I'm saying it collapsed from the bottom up. So these floors try to hold on as long as they could. Some sections here, and it pulled away. It had a hell of a pull away. So I can tell you, it pulled away at least 8 feet, approximately about 8 feet here. It's the height of a ceiling. I don't know if they're 8 or 10s, but that's the finished plaster, I believe. And this steel, if we were to stand it up there to this floor, the finished floor here, it's about 8 feet, I'm guessing. And then, interesting, I want to get to this piece of steel down. These steel, they've totally, that can't be steel. It must be plastered lath or something. This steel is folded over pretty far, and it just stripped it off. So I'm going to say you have a bonding issue here of the concrete. It just stripped this totally off, but not on this side. So it didn't pull down the rest there. This structure was able to take the weight of what was being pulled at it floor by floor. Each floor did. So let's call it the contractor was different than see, this is what I expected, some of this, where you still have some engagement of the rebar. But there's no engagement of the rebar here, just all pulled away. It's just stripped. I mean, here's a little bit there. Here's more here. So we could say the contractor's concrete was a little bit, let's say, soft, the pull-out test. I think I just talked to you guys about pull-out tests on reinforcement. They're right about could crumble, that's for sure. Look at our reinforcement. Just this little piece is sticking out, which allowed it to create a shear plane. Over here, look at that. Practically none at all sticking out. There's a little nub there. And this was definitely a room engaged there. I mean, you just didn't walk into the bedroom sideways. So there was a bed here. There's a bed here. So this concrete, and now here's some reinforcement that's longer. But here, there's no reinforcement. Right inside this image here. Here's a J hook, J bar. So there's your J bar, and it tells you what they were up to there. Let's see if I can screenshot that. Wow, look at the little piece there, and it's so far out. So this was a little bit of pull out, but 1, 2, 3, 4, 5, 6, 7 pieces of rebar. And down here we have a little piece at the top. There's a long piece with something on it. There's some over here. Here's the outside wall column and porch. Okay, I misread that angle of the tear off. Here's the angle of the tear off this direction. And it might be the design, but it looked like it was coming back towards me. And I obviously, this now shows, is in the way, this hammock shows this is behind the hammock. So this is the front of the building, or the street side, one of the street sides. Like that's the street side, that's the street side. There's the angle of the door. You can see it being torn off that way. Yeah, these people probably didn't make it if they were there. Had a dog up there. And where's the reinforcement? Where's the reinforcement? This buckle down here looks like the plane here, and then this concrete looks like it's missing a nice chunk of concrete here. And this is where these guys were. 1, 2, 3, 4. These units look like they all came through this hole here. And then we have this fracture here. That's the wall trying to rotate outwards and tear it. There's a rotation in, and that's exposed concrete at the top of the wall. I mean, a reinforcement appears. So you would think that would be. I'm looking for a mechanical shaft or something like that, but here's our shear plane because there's lack of reinforcement. So my instincts want to say it's the column, but